Welcome viewers, in this video we'll see the star delta transformation. How the impedances are connected in different configuration. In electrical network, the impedances can be connected in various configuration. The most of these configuration are either star or delta connected network. In general, it is connected either in star connected or delta connected. To solve complex electrical network or simplifying it, we use star delta transformation technique. The complicated network can be, in order to simplify this, we can convert from star to delta or delta to star, so that the circuit becomes simpler. We can go for further analysis. So we need a star delta transformation technique. It replaces any star connected network with its equivalent delta connected network and vice versa. So we can convert star connected network to delta connected or delta connected to star connected. Right? So for simplification, for analysis purpose, we need this conversion technique. First we will see what is the delta connected network. So this is the delta connected network, that is the resistors are connected, impedance are connected end to end. One end of the resistor connected with another end of another resistor. In delta connected network, it formed by connecting impedances end to end. One end of the resistor is connected to another end of the resistor. So from this we can take the three phase. Here named as the term, the corners are named as A, B and C. The resistor values are R1, R2, R3. Resistor connected end to end is called a delta connection. The resistor value R1, R2, R3. Then we'll go to the star connected network. In star connected network, three phase wires are connected to a common point. One end of three impedances are connected to the common point. From that we can take the neutral. So other three terminals are open. So from that we can take three phase. So in delta connected, all end to end the resistors are connected. There is no common point, but here one end of all three resistors are connected together. That is called a neutral point or common point. The remaining terminals are available. From that we can take the three phase. The name is A, B, C. The resistor value is RA, RB and RC. In delta connected, R1, R2, R3. In star connected, RA, RB and RC. Now we'll go to the delta to star transformation. So first transformation we'll see delta to star transformation. This delta connected network can be replaced with the star connected network. R1, R2, R3. Now we are going to replace with RA, RB and RC. Right. In this diagram, the above diagram shows the delta network having terminal ABC with impedance R1, R2, R3. The terminal name is ABC. The resistor value, impedance value is R1, R2, R3. The equivalent star connected network with RA, RB, RC, where they are connected to the corresponding terminals as shown in the diagram. So this R1, R2, R3 is very equivalent to RA, RB, RC. The terminals ABC remain the same, as well as the impedance between them must be the same. So that is based on this principle we are going for a transformation. That is the impedance across the terminals. What is that impedance across the terminals? So the impedance across AB is equal to, in the delta connected network, is equal to the impedance across AB in star connected network also. That is RAB in delta network is equal to RAB in star network, because the terminals are remain same. The impedance between these two terminals in both the delta and star connected network are equal. Based on that, we can go for a transformation. Now we'll start the derivation. Now consider this delta connected network. This one should be replaced with star connected. The term A, B. The total impedance between A and B in the delta network. Only A and B we consider. C we are not considering. We are going to find what is the impedance across AB. So the term C is not available, not applicable. What is the impedance across AB? In between A and B, R1 is connected. But other end, R2 and R3 also connected. This R2 and R3 are series because C we are not considered. We are considered only AB. So that these two are become a series combination. R2 plus R3. So that is connected in series in parallel with the R1. Right? So between A and B we have R1 and this R2 and R3 connected in series, that is in parallel with R1. Right? So that is given here. R1 is parallel with R2 plus R3. Right? So these two are parallel combination. In that one series is available. So the resistance between RAB is nothing but R1 connected in parallel with R2 plus R3. Right? So what is the parallel resistor? R1 R2 divided by R1 plus R2. These two should be multiplied and these two should be added. That is the formula. R1 R2 divided by R1 plus R2. So that R1 into R2 plus R3 divided by R1 plus R2 plus R3. These two resistors multiplied and added. That is the basic formula for parallel resistors. Now we'll go to the next terminal, B and C. Now the same delta connected network, we'll consider this B and C. Previously AB, now B and C. What is the resistance impedance between B and C? See, this R3 is connected. R3. That is in parallel with R1 and R2. Right? This R3 parallel with R1 and R2. We are not consider this point A because we consider only B and C. So this become a normal terminal. So that this R1 and R2 are connected in series, that is in parallel with R3. So that is given. R3 in parallel with, this symbol is nothing but parallel, R1 and R2, R1 plus R2. Then how will you find the impedance for a parallel combination? That is nothing but multiplication of these two divided by sum of these two. R3 into R1 plus R2 divided by R1 plus R2 plus R3. You take this equation number 2, previous one equation number 1. Now we'll go to the next terminal, next two terminal, total impedance between C and A. First AB, BC, now C and A. Well, C and A, this terminal B is not considered. It's an open normal terminal. What is the resistance impedance between this C and A? R2 in parallel with R1 and R3. R2 in parallel with R1 plus R3. These two are connected in series, that is parallel with R2. What is the equivalent resistance? Multiplication of these two divided by sum of these two. R2 into R1 plus R3 divided by R1 plus R2 plus R3. So take this equation number 3. Now we found the expression for RAB, RBC and RAC based on the delta network. That equations are termed as equation 1, 2 and 3. Now we'll go to the star connected network. The same resistor based on star connected network. What is the resistor? What is the resistance value RAB? What is the resistance connected between RA and B? If we consider A and B, C is not considered. In between A and B, only RA and RB is connected in series. This terminal is open. C is not considered. If C is not considered, means this will be open. Only this RA and RB are connected in series. So in star network, the resistance between A and B is RA plus RB. The resistance between B and C, these two, that means this is not considered. Only B and C. What is available between B and C? RB plus RC. These two are connected in series. RB plus RC. What about the resistance between RCA, C and A, these two? Then this terminal is not considered. Between C and A, RA and RC is available. RC plus RA. Right? So now we found the expression for RAB, BC and CA in case of star network also. That equations are equation 4, 5 and 6. Now we got 6 equations. First 3 equations based on the delta network. The next 3 equations based on the star network. Right? I think you are able to understand this. RAB means RA and RB are connected in series. This is become open terminal, not considered. Now we'll go for the further simplification. In order to convert, we are adding the equation 1, 2 and 3. What is equation 1, 2 and 3? In case the delta network, RAB plus RBC plus RCA. On other side, what we have? R1 into R2 plus R3 divided by total resistor plus R3 into R1 plus R2 divided by total resistor plus R2 into R1 plus R3 divided by total resistor. This is nothing but equation 1, 2 and 3. Both the sides are added. Now what is the value of RAB BC from equation 4, 5, 6, that is star connected. We are substituting this value from equation 4, 5, 6. RAB is nothing but RA plus RB. RBC is nothing but RB plus RC. RCA is nothing but RC plus RA. Right? These 3 values are substituted from 4, 5, 6, that is star connected network. Now we'll go to this right hand side. Right hand side, all these 3 are same. So we can take it as LCM, common. R1, R2, R3 is available in all the terms. We can write the remaining terms. R1 into R2 plus R3. R3 into R1 plus R2. R2 into R1 plus R3. Right. Now see this. RA available 2 times. RB available 2 times. RC available 2 times. So we can write 2RA plus 2RB plus 2RC. And here you multiply the terms inside. R1 into R2. R1 into R3. R3 into R1. R3 into R2. R2 into R1. R2 into R3 divided by R1 plus R2 plus R3. Now we'll go for a further simplification. So this is available 2. You can take 2 outside. 2 available in all the time. So 2 times of RA plus RB plus RC. Similarly here R1 R2 available 2 times. R1 R3 available 2 times. R3 R2 available 2 times. So 2 times of R1 R2 plus 2 times of R2 R3 plus 2 times of R3 R1. Right? Here also you take the 2 outside. So this 2 got cancelled. So finally what we have? RA plus RB plus RC equal to R1 R2 plus R2 R3 plus R3 R1 divided by R1 plus R2 plus R3. After all simplification we got this. But what we need? Only RA. So this is the delta connected. We need to convert into star connected. So RA is needed. So keep this RA and RB and RC is brought into right hand side. From left side to right hand side. This RB and RC is brought to the left hand side. Right hand side. So it become minus RB RC. So RA equal to this term minus RB plus RC. What is RB plus RC? Can be written as RBC based on the equation 4, 5, 6. Right? Now we have RA this term minus RBC. So RBC value, this RBC value can be substituted from equation 2. Equation 2 we have the value of RBC. What is that? R3 into R1 plus R2 divided by total resistance. Now see this, one side we have star equivalent resistor. This side we have only delta resistors. So by simplifying this we can find the value of RA. I will go for the further simplification. So the further simplified as this term minus, that is multiplied inside. Now the denominator, both the values are same, so we can take it as common. Now these terms are written. This R2, R3, this is negative is there. So R2, R3 here, R3, R2 plus. This one is minus and one is plus. So these two got cancelled. Similarly R3, R1, one is plus, one is minus, got cancelled. Finally we have only this term. R1, R2 divided by R1 plus R2 plus R3. Now we got the equivalent RA value, star connected network, in terms of delta connected network. So similarly we can write the remaining RB and RC. RB equal to R1 R3 divided by R1 plus R2 plus R3 total resistance. Similarly RC equal to R2 R3 divided by R1 plus R2 plus R3. Then how will you remember this value? See this again, this delta connected diagram is available. R1, R2, R3. RA, what is RA? See this RA, this is a A. What are the resistor connected? R1 and R2. So that is available. R1 plus R1 into R2 divided by total resistance. This total resistance are common. Similarly RB, this is terminal B. What are the resistors available? R3 and R1. That is multiplied. You can easily remember. Similarly RC, this terminal C. What are the resistors available? R2 and R3. So that R2 by R2 into R3 divided by total resistance. So RA means what are the resistor connected? You have to multiply. You can easily remember. Now we converted delta to star. Now we'll go for the star to delta conversion. So in this, these three are taken as equation 7, 8 and 9. So from this 7, 8, 9 only we can proceed for further simplification, further transformation, right? Already we have 6 equation. Now this is 7, 8 and 9. Now we'll go to the star to delta transformation. Delta to star is completed. We'll go to star to delta conversion. So now we have already 9 equations are available. In order to find the equivalent delta resistance, multiply equation 7 and 8. Already we have 7, 8, 9, 3 equations available, RA, RB, RC. In that we are multiplying equations 7 and 8, RA and RB. So these terms are available. So denominator both are same. So R1 plus R2 plus R3 is the whole square. Here R1, R2, R1, R3. R1 available 2 times. So R1 square, R2, R3 divided by total resistance square. This is equation number 10. Now multiply equation 8 and 9. RB and RC. RB and RC. Same thing. These two are same, so that R1 plus R2 plus R3 the whole square. Here R1, R3, R2, R3. R1, R3, R2, R3. R3 available 2 times. So R1, R2, R3 square. So this take this equation as 11. Previous one equation number 10. Now multiply the equation 7 and 9. Multiply the equations 7 and 9. RA and RC. So the denominator same, R1 plus R2 plus R3 the whole square. Here available R1, R2, R2, R3. So R2 available 2 times. So R1, R2 square into R3. This is equation number 12. Now we got equation number 10, 11 and 12. That is RA, RB, RB, RC, RC and RA. These 3 equations are we framed. Now we'll go for the further simplification. Now we are going to add these 3 equations. Equation 10, 11 and 12. What we framed now earlier, we are going to add. That is RA, RB plus RB, RC plus RC, RA. Then these 3 terms. The denominator same. Total resistance square. Here R1 square is there. Here R3 square is there. Here R2 square is there. So denominators are equal, so we can take it as common. We can write all these 3 terms. So in this R1, R2, R3 available in all the three terms. Only here R1 square, R2 square, R3 square. So R1, R2, R3 available in all three terms taken as outside. So while taking R1, R2, R3, what will happen here? R1 is available. Here R2 is available. Here R3 is available. Remaining. So R1, R2, R3 taken outside, the remaining values are written. So this is, both are same. So one term got cancelled. This one term got cancelled. So after that what we have? RA RB plus RB RC plus RC RA equal to R1 R2 R3 divided by R1 plus R2 plus R3. After simplification we got this value. Now we are going to rewrite this. How we are rewriting? R1 R2 divided by R1 plus R2 plus R3, and this R3 is written separately, right? This R1 R2 written here, R3 written separately. What is this R1 R2 divided by R1 R2 plus R3? From equation 7, this R1 R2 divided by R1 plus R2 plus R3 is nothing but RA. You can refer from equation 7. So this term can be replaced as RA, right? Now bring this RA in the denominator, so that R3 equal to this term divided by RA, so that we can write R3 equal to RA RB plus RB RC plus RC RA divided by RA. It is interchanged. So based on this value we can write R2 and R1 values also. So the numerator is same for all the three terms. Only in R3 we need to multiply, divide by RA. R2 divide by RB. R1 divided by RC. That also we'll see in the diagram. How will you identify? R3 means RA. R2 means RB. R1 means RC. That also we'll see. So now we completed the star to delta conversion also. Now we'll summarize this. So after two transformation completed, just will summarize all this. This is a delta connected network. R1, R2, R3 is available. This is a star connected network. RA, RB, RC is available. Right. Now we formed the two transformation we completed. This is a value R1, R2, R3 in terms of star connected. RA, RB, RC in terms of delta connected. Right. So this one I already explained how to find the RA. RA means the terminal A, this R1 and R2 is available. From that easily identify. Similarly, how will we find this R1? R1 equal to, what is R1? Where is this available? In between A and B. Similarly, what is available in between A and B? RA and RB. You have to refer the other terminal resistance, RC. Right? So the R1 means RC. How we can easily remember? R1 is connected between A and B. So in between A and B what we have? RA and RB. The rest of the resistor is RC. So the rest of the resistor you have to divide. By that you can easily remember. Right? So we have all two type of transformation completed. Star to delta and delta to star. So in this, suppose if all resistors are equal, right, in star connected, RA equal to RB equal to RC equal to R star, then what will happen? R delta equal to 3 times of R star. So if you substitute in the previous equation, you can easily found this, you can easily remember. R delta, if all resistors are equal, R delta equal to 3 times of R star. Suppose delta, all resistor in the delta connected network is same. R1 equal to R2 equal to R3 equal to R delta means the R star equal to R delta divided by 3. That is based on the expression we calculated. So you can easily remember, right? If all resistors are equal, you can use this formula. So in this video we discuss what is the transformation, what is the star connected network, what is the delta connected network, then delta to star transformation, then star to delta transformation, then summarize, and what are the If all the resistors are equal, what is the equivalent value? These things are discussed. Thank you.